Hey guys, welcome to my channel. Today we are going to discuss about generative AI, which is in the realm of artificial intelligence. Generative AI generates the content that includes images, text, videos, and many more, and it achieves this by learning the pattern behind its trained data and tries to mimic it. It helps us to be more productive in our domains, and we also know how successful generative AI applications are. Here we have some of the key concepts to master it. Model architecture. Many models that are used in generative AI applications are a merge of foundational models or they are built on top of it. Training, transfer learnings, techniques for optimizations are crucial to enhance the stability and performance of the model. This model generates the outcome based on input prompts and the training data. So it can generate a wide range of outputs, and the output behind the black box is hard to trust. So the transparency, bias, and fairness of AI are very crucial to gain the public trust. So ethical AI is very important, and having regularity frameworks in AI development helps us to maintain better ethical standards. Generative AI applications can help create a new and better world by expanding what we can do, making us more productive in areas like healthcare, education, research by developing chatbots, data augmentations, and simulates data by mimicking the real data distribution. Deployment. It is a very crucial task because our models need to work with scalable data. As data continues to grow every day, our applications must be able to handle this increasing volume efficiently. Looking ahead, future trends of AI holds immense potential. There are many untapped opportunities that could drive significant business growth and creativity. So by keeping pace with emerging trends and breakthroughs, we can be at forefront of AI. Let's look into model architecture. These are some of the important models which are used regularly in generative AI applications. Transformers. They are a type of neural network which have revolutionized the way we process sequential data, especially in natural language processing. Transformers are designed to handle input sequence in parallel. It processes the input sequence at once with the context, as it uses self-attention mechanism which allows the model to weigh the importance of different words in a sentence regardless of their position. This means transformers can understand context far better than older models like recurrent neural network. As they do not have built-in order, they use positional encoding to maintain the context and use multi-head attention to look at different parts of the data in various ways at the same time. This helps the model understand the information in a better way. Think about how GPT and BERT handle language generation, or how DAL-E generates images. That's the power of transformers. They are incredibly versatile. They can handle massive datasets, scale up with ease. As they work in parallel, they are making them faster and more efficient. Next, let's dive into variational autoencoders. They are a type of generative models that learns to encode input into a latent space and then decode it back into a data that resembles the original input. Variational autoencoders work by encoding data into a latent space with a probabilistic approach, allowing for smooth interpolation between data points. The key here is the KL divergence, a measure that ensures the distribution in the latent space is close to a known distribution, like a normal distribution. This helps the model generate new realistic data points by sampling from this latent space. KL divergence is crucial because it regularizes the latent space, preventing the model from simply memorizing the training data. It encourages the model to generate diverse outputs that still follow the underlying data distribution. VAEs are often used in generating new images that look like they belong to the same set as the training images but are entirely new creations. VAEs are perfect for applications that regularly require smooth transitions and interpolations between data points, such as image generation, anomaly detection, and even data compressions. Now, let's talk about diffusion models. They are generative models that create data by reversing the process that gradually adds noise to it. Think of it as starting with random noise and refining it until you get a clear, realistic output. The model learns how to step by step remove noise from the data until it reaches a point where the data resembles something real, like a high quality image. Diffusion models are particularly powerful in generating high fidelity images and videos, where the quality and realism of the output are crucial. These models are becoming a go to for applications where you need precise and high quality generation, like in video editing or scientific simulations. Next on the list are generative adversarial networks or GANs. GANs consist of two neural networks, a generator and a discriminator, that are trained together in a kind of game. The generator tries to create fake data while the discriminator tries to figure out if the data is real or fake. As the two networks compete, they both get better. The generator creates more convincing fake data, and the discriminator gets better at spotting the fakes. This adversarial training pushes the generator to create incredibly realistic outputs. Traditional GANs often struggle with training stability. This is where Wasserstein loss comes in. Instead of focusing on whether the data is simply real or fake, Wasserstein loss measures how close the generated data distribution is to the real data distribution. This provides smoother gradients, making the training process more stable and effective. GANs are well known for creating deepfakes, images or videos that are so realistic they can be hard to distinguish from the real thing. GANs are incredibly powerful for generating high resolution images, video content, and even audio. They are used in everything from creating virtual environments to enhancing old photos. Now, what happens when we combine these models? Let's look at some great combinations and their use cases. If we combine VAEs and GANs, high resolution image generation in fields like photography and virtual reality, the VAE provides a smooth latent space, and GAN ensures that fine details are realistic. When we combine VAE with diffusion model in image and video interpolation, this is perfect for animation and video editing, as VAE handles smooth transition while diffusion models ensure high quality outputs. When we combine both GAN and diffusion models, super resolution and image enhancement, this is ideal for satellite imaging or medical diagnostics, as GAN generate the enhancements and diffusion models refine the output to perfection. Finally, let's talk about fine tuning. Fine tuning is the process of taking pre-trained model and refining it on a smaller specific dataset to make it excel in a particular task. You start with a model that's already been trained on a large dataset like GPT-3, and then adjust its weights and biases to make it better at a more specialized task, like writing a legal document or generating art in a specific style. Fine tuning is often used in NLP tasks. For instance, you can fine tune a general language model to become an expert at medical text generation. Fine tuning saves time, computational resources, because you don't need to train a model from scratch. It also allows models to be more specialized and effective in the niche areas. And now let's look into ethical AI. In this section, we are diving into ethical AI, a crucial part of developing and deploying generative AI systems. By focusing on these areas, we can build AI models that are fair, transparent, and aligned with societal values. First, bias mitigation. To ensure the fairness, it's essential to address bias at the data level. This can involve techniques like reweighting, where underrepresented groups are given more importance, or adversarial rebiasing, where models are trained to minimize bias. For example, in healthcare AI, using diverse patients' demographics in training data can help prevent biased treatment recommendations. Next, we have fairness audits and continuous monitoring. It's not enough to just start with fair data. We need to regularly check how our AI model perform across different groups. For instance, if an AI tool used for hiring shows a bias, a fairness audit can identify and correct that issue. Ongoing monitoring after deployment helps catch new biases before they become problems. Data privacy and transparency are key. Techniques like differential privacy, which adds noise to protect individual data, or federated learning, where models are trained without sharing data, are crucial. And it's equally important to be transparent about how AI model makes decisions. For example, in credit scoring, explaining how a score was determined builds trust and allows users to challenge any unfair results. Involving stakeholders, especially from marginalizing groups, ensure that we have considered different perspectives in AI development. For instance, consulting advocacy groups when developing facial recognitions can help spot ethical concerns early. Adding a human in the loop, especially in sensitive areas like criminal justice, ensures that AI decisions can review by people, adding accountability. Staying compliant with regulations like GDPR in Europe or CCPA in California is both a legal and ethical necessity. These laws protect user rights and set standards for data protection. Beyond that, companies should develop their own ethical guidelines to reflect best practices, helping to avoid penalties and foster a culture of responsible AI. Finally, using ethical AI tools can improve fairness and transparency. Tools like IBM's AI Fairness 360 help evaluate models for bias, and Google's What If tool lets you explore how different inputs affect outcomes. Conducting impact assessments before deploying AI ensures you catch any ethical risk early, like avoiding unintended bias in predicting policing models. These are some of the trainings and techniques that are crucial to enhance stability and performance of our model. Adversarial training, which particularly used in GANs and in generative AI, it's crucial that models generalize well to new data. Regularization techniques like dropout, weight decay, and spectral normalization help avoid overfitting by controlling complexity and reducing over dependency on specific data patterns. These methods ensure that the model can produce high quality and generalized results. Dynamic learning rate schedules such as cosine annealing are particularly used in generative AI training. These schedules adjust the learning rate over time, allowing the model to learn efficiently without overshooting or getting stuck in local minima. This results in faster convergence and better overall performance. Data augmentation is key to improving the robustness of generative AI models. Techniques like random cropping, flipping, and noise injection expand the training data, teaching the model to handle variations and improve its ability to generate diverse and high quality outputs even from limited datasets. Finding the right combination of hyperparameters is essential in generative AI. Methods like grid search, random search, and Bayesian optimization allows you to efficiently explore the best hyperparameters for your model. This step is crucial for maximizing the quality of generated content, be it images, text, or audio. In generative AI, using advanced optimizers like Adam, Random, LAMB can significantly improve training stability and convergence. These optimizers dynamically adjust learning rates, ensure that model train faster and more reliably, especially when dealing with larger and complex generative tasks. These techniques ensure that your models not only train efficiently but also produce high quality and realistic outputs, pushing the borders and boundaries of what's possible in AI generation. Let's take a look at how generative AI is being used across different industries. From creative arts to scientific research, this technology is changing the way we innovate and solve problems. First, let's talk about creative industry. Generative AI is transforming the arts, media, and entertainment by automating content creation. Whether it's designing logos, composing music, or generating stories, AI allows for personalized and innovative experiences. For example, AI can create custom music tracks in a video game that adapt to what the player is doing in real time. In healthcare and biotechnology, generative AI is speeding up drug discovery and creating personalized treatment plans. It also it's also important in sustainability, helping to design eco-friendly solutions. Imagine an AI system that generates new molecular structures for drugs, cutting down the time needed for research and development. Generative AI is also a big deal in data augmentation, where it enhances machine learning by creating synthetic data for better model training. In education, it personalizes learning experiences for each student and it fosters collaboration between humans and machines, enabling innovative partnerships across fields. For example, AI can generate datasets to help train models that recognize rare medical conditions. In urban planning and architecture, generative AI optimizes designs for buildings and cities, making them more efficient and sustainable. In financial services, it models market behavior and aids in risk management, helping organizations make smarter decisions. For instance, AI can create multiple architectural designs based on criteria like energy efficiency, allowing architects to explore more creative solutions. Generative AI also streamlines work in legal, security, and regularity areas. In it automates routine tasks, generates necessary documentation, and improves security through advanced simulations. This ensures compliance with regulations and boosts overall efficiency. For example, AI can generate legal contracts that automatically adjust to new regulations, saving time and reducing errors. Finally, generative AI is accelerating research by generating hypotheses and simulating complex social behaviors. This leads to breakthroughs in science, sociology, and public policy. For instance, AI can simulate the impact of policy changes on a population, helping policymakers make better decisions based on likely outcomes. Generative AI is a powerful tool across many industries, driving innovations and improving efficiency. Whether it creative arts, healthcare, urban planning, or research, the applications of generative AI are broad and transformative. By understanding and using these technologies, we can unlock new possibilities and build a more innovative future. When it comes to deploying generative AI, there are several critical factors you need to get right. These elements aren't just technical details, they are what make your AI application effective, scalable, and secure. Let's break down why each of these considerations is important, how they help, and how they work in real world generative AI application. First up is optimization and cost management. In generative AI, getting the best performance from your model is crucial. This is where hyperparameter tuning, model pruning, and efficient resource allocation comes into play. These techniques help your model run faster and more efficiently, which is especially important when dealing with large data sets or complex tasks. Plus, by managing costs, whether it's through optimizing cloud usage or choosing the right hardware, you ensure that your AI projects are not only powerful but also sustainable in the long run. Next, let's talk about scalability and containerization. As your generative AI applications grow, they need to handle increasing workloads without a hitch. Scalability ensures that your system can expand smoothly using techniques like horizontal scaling and load balancing. Containerization, like tools like Docker and Kubernetes, makes sure that your AI models can be deployed consistently across different environments. This means whether you are deploying on the cloud or on premises, your model will work seamlessly, allowing for easier management and faster scaling. CI CD pipelines, continuous integration, and continuous deployment are all about keeping your AI models up to date and in the top shape. By automation of the integration, testing, and deployment processes, CI CD pipelines allow you to make rapid updates to your models without introducing errors. This is particularly important in generative AI, where models often require frequent adjustments and fine tuning. With a solid CI CD pipeline, you can ensure that your AI applications are always running the latest, most effective versions. Monitoring and model management are essential for maintaining the health of your generative AI applications. Real time monitoring allows you to track key metrics like latency, performance, and resource usage so you can quickly identify and address any issues. Effective modeling management practices like version control and rollback mechanisms ensure that you can revert to a previous model version if something goes wrong. This kind of proactive management keeps your AI applications run smoothly and effectively and efficiently over time. When dealing with the heavy computational demands of generative AI, GPU quantization and VRAM efficiency become crucial. GPU quantization involves reducing the precision of your model's computation, which helps to lower VRAM usage without sacrificing accuracy. This is particularly useful for deploying large models on resource constrained hardware. By optimizing VRAM efficiency, you can ensure that your models can run smoothly across a wide range of devices, making them more versatile and accessible. Finally, security and compliance are vital for protecting your AI models and the data they handle. In generative AI, where data can be highly sensitive, robust security measures like encryption and access controls are essential. Additionally, staying compliant with industry regulations such as GDPR or HIPAA ensures that your AI application adhere to legal standards and protect your user privacy. This is not only safeguards your organization from legal risk but also builds trust with your users, which is crucial for the long-term success of any AI project. In summary, each of these considerations, optimization, scalability, CI CD pipelines, monitoring, GPU efficiency, and security, plays a critical role in the success of generative AI applications. By focusing on these areas, you can deploy AI models that are not powerful and efficient but also secure and reliable. These strategies help you navigate the complexities of AI deployment, ensuring that your applications deliver consistent and high quality results. Generative AI is evolving rapidly with several key trends shaping its future. Multimodal AI integrates data types like text, images, audios, and videos, enabling richer and more complex content creation, as seen with models like OpenAI's DALL-E. Personalized and content aware AI will create tailored experiences for users, enhancing engagement in areas like marketing and virtual environments. Ethical AI is becoming increasingly important, focusing on fairness, transparency, and responsible use, essentially in sensitive areas like media. AI is also transforming creativity, working as a collaborator in fields like art and music. In scientific discovery, AI accelerates breakthroughs in drug design and environmental modeling. Real time and low latency AI applications like gaming and interactive storytelling are now possible due to hardware advancements. Sustainability is another growing focus, with new methods like model distillation reducing AI's environmental impact. Finally, AI is expanding into new areas like autonomous system and finance, pushing the boundaries of what AI can achieve across industries. If you want to stay ahead of the curve in AI, make sure to like, share, subscribe, and hit the notification bell for more insights into the world of generative AI.